Hey guys, Mr. Wilson here. Today we're going to talk about zero and negative exponents. At the end of this video, you should be able to simplify exponents containing simplify expressions containing zero and negative exponents. Okay, so let's start. What is an exponent? I have to go into this a little bit. Let's simplify this first. X plus x plus x plus x plus x. What is that? That's 5x. Notice that now all this addition turned into multiplication. And multiplication is repeated addition. Okay, understand we say multiplication because when we say 5x, that means 5 times x. Okay, simplify x times x times x times x. Well, that's x to the 5th. Okay, exponents are repeated multiplication. So in the same way that multiplication is to addition, exponents are to multiplication. So let's talk about terminology a little bit. The base number is the big number. Okay, like visually big. Okay, so in this case, 2 is the base. The exponent is the small number, 8, superscript. Okay. Okay, the power, 8, 2 to the 8th. Okay, 2 to the 8th power. It's the whole thing. Whole thing, that's what we call the power. Okay, so 2 is the base, 8 is the exponent, 2 to the 8th is power. So 2 to the 8th power. Alright, so let's look at how we can find some patterns in these zero and negative exponents. 3 to the 4th is 3 times 3 times 3, 81. Okay, what's the pattern in the first column? 3 to the 3rd, 27. 3 to the 2nd, 9. 3 to the 1st, 3 times 3. Okay, so what's the pattern in the first column? We see in this first column, what's happening is that the exponent decreases by 1. Okay, what is the pattern in the last column? What's happening? 81, 27, 9, 3. Well, each time we can see that the number is divided by 3. Okay, 81 divided by 3 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. Okay, so now using this information, we're going to continue this pattern. Okay, 3 to the 0, if we continue this pattern, it should be 1. 1 divided by 3 should be 1/3. 1/3 divided by 3 should be 1/9. Okay? Notice here. 3 to the 1 is 3. 3 to the negative 1 is 1/3. Notice it is not a negative number, but what did happen is, instead of the 3 being in the numerator, when it was negative, it's in the denominator. 3 to the 2nd is 9. So 3 to the negative 2nd is 1/9. Okay, so for me, tell me what 3 to the negative 4th would be. Okay, write that here, fill that out, so when I'm checking your notes, I know you listened and I know you thought about this and understand that rule. Okay, so let's focus on this really quick. 3 to the 0. Notice that 3 to the 0 was 1 following that pattern. For every number a to the 0 is going to be 1. No matter what number, when we get to that pattern, when we get to the 0, it'll always be dividing something by itself, which will be 1. So 15 to the 0, 1. 3,142 to the 0, 1. Negative 23 over 61 to the 0, 1. Notice that the negative is inside the parentheses, so that's a part of the power. Okay, but 1. Okay, so anything to the 0 power is just 1. Okay, big idea number 2 here, guys. For every number a, the integer in a to the negative n is just 1 over a to the n. Okay? Here's the trick that'll help you remember. If there's a negative exponent, its base is not negative with where it is at in the... If there's a negative exponent, trick to help you remember. If there is a negative exponent, its base is not... Oh. Okay, here's a trick to help you remember. If there's a negative exponent, its base is not happy with where it is in the fraction. Okay, so if its base isn't happy with where it is in the fraction, you need to move it so that it's happy. So it's not negative anymore. Alright, so here's some notes. We'll go through a few of these. I'll have you do a few of these on your own. Simplify each expression. You should have no negative numbers or no negative exponents in your answer. So let's go through this. Here we have x to the negative fifth. Okay, remember that every number, so when we're done simplifying, we should have no negative exponents. And remember that every number is a fraction. So even this is a fraction. So what we're going to do is, this is a negative exponent. We need to move it. Okay. When we move it, there's nothing left on top or on the bottom. Wherever we move it, it becomes 1. And so we move the base with it. And so we move that down because it was negative, and so we have 1 over x to the fifth. Number 2, we have 1 over x to the negative ninth. Again, negative exponent means it's not happy where it's at. We need to move it. So we have x to the ninth. And in the denominator would be 1. So we don't really have to write over 1. Doesn't help us out any to do that. Okay? If it does, you can, and put over 1. It makes you feel like, okay, I'm complete, but it's fine. Okay, number 3. Now, here's where we have to start making sure that we are paying attention to what the exponent goes with. Remember that we're only moving the powers together. So we have 7x to the negative third power y to the fourth. These are combined. These are linked. X to the negative third are linked. But 7 and y to the fourth are their own number. Okay, so if x to the negative third isn't happy, that's the only thing we move. Okay, so now we have 7 y to the fourth. They were happy in the numerator. We keep them there. Over x to the third. Okay. For number 4, we have 5 to the negative second. Here, negative exponent, we need to move it. And so we have 1 over 5 squared. Now when we were just dealing with variables, we just kept it as they were. If we can simplify these, especially numbers that you're familiar with, feel free to simplify. 1 over 25. Okay. Number 5, negative 22.4 to the 0 power. Remember that anything to the 0 power is just 1. Number 6, did they write the same question twice? Nope, there's a difference. In number 5, the negative is inside the parentheses. In number 6, the negative is outside of the parentheses. So for number 6, we have 22.4 to the 0 power, and then there's a negative here. So it would be actually negative 1. Okay, because 22.4 to the 0 power is 1, times negative 1 is negative 1. Okay, for number 7, we have a to the negative 6th, needs to move. We have b to the negative 4th, that needs to move. Remember to keep those exponents tied to their base. So for 7, we should have b to the 4th over a to the 6th. Okay, number 8. Negative exponent needs to move. So I have 1 over negative 2 to the third. Okay? And I can simplify that. That's 1 over negative 8. Negative 2 times negative 2 is 4, times negative 2 is negative 8. Okay? Here we have that to the bottom. 1 over negative 2 to the third. And 2 to the third is 8. Negative would be negative 8. Okay? Ends up being the same thing. Okay? And that's just because 2 to the third would be 8 and negative would be negative 8. Negative 2 to the third, again, we already went through that, so it's just the same thing. Okay? But we had to approach it a little bit different. Number 10, negative exponent with the x. Okay, so remember those are tied together, but 4 is its own number. So 4 is fine. Its exponent, really, let me talk about that here. Its exponent, if there's no exponent written, is 1. Okay, that means it's a positive exponent. It stays. Okay, this x had a negative exponent. It needs to move. So x squared, y to the 7th. Okay, number 11. Now these problems look tricky, but I'll tell you that the best technique that I have for it is just doing exactly what we've been doing for every other problem. Look at everything individually and one at a time. So I have 3. Its exponent's negative. It needs to move. I have n to the negative 5th. Its exponent's negative. It needs to move. I have k to the 0. Well, that's just 1. Okay? And so now, and I have m to the 4th. It's fine. It's positive. It stays where it's at. So now what do I have left on top? Well, I moved everything down, so I just have 1. So now in the denominator I have 3 squared, m to the 4th, n to the 5th. And I usually just try to write in alphabetical order because that way I know I've gone through everything. Okay? And if I really want to, I can rewrite that as 1 over 3 squared is 9, m to the 4th, n to the 5th. For number 12, the last one, I am going to leave that to you. So try that out one at a time. Do that. Okay? Evaluating expressions. Here's my strong recommendation for you. I'm going to tell you to simplify the expression before putting the numbers in for the variables. And so what that means is make all the exponents positive and then throw the numbers in. Don't just think you're going to plug numbers in and get it right. It doesn't work that way. I know it would be nice to work that way, but it doesn't. So do the work first. So for this example, we have 4m to the negative third into the negative over into the negative second. What we'll need to do before we start our work is we need to simplify this. So I'm going to have to move that down, move this up. So I'll have 4n squared over m cubed. Okay? And now I'm going to plug in those values. So 3 squared over negative 2 cubed. 3 squared is 9. 9 times 4 is 36. Negative 2 cubed is negative 8. Okay. And now I'm going to simplify that. That 4 goes into both of those. And so I'll have a 9 over negative 2. Okay. And so I could keep it like that as negative 9 halves. Or I could keep it as negative 4.5. But either of these two, I think either of these two is an acceptable answer. This will be how I want it, not as a decimal. That way I know that you are using your mind and not your technology. Okay. So along with number 12, have this one done for me. Okay, guys. All right. See ya.